The sun is a force to be reckoned with. It has been painting the surface of our planet with ultraviolet rays for billions of years. So why are we melting now? Good day, class. I'm Matt Guilfoy, and today I'll be discussing the meltdown, how climate change is impacting the Arctic and melting Arctic ice. Rising global temperatures have had a negative impact in various regions across the globe, most notably in the Arctic region. These impacts have caused a recession of Arctic sea ice, reducing our planet's capability of regulating the global climate and reducing the habitat of the polar bear. Seasonal changes in the Arctic have helped to regulate the global climate for millions of years. In the last 40 years, the sea ice extent in late winter would cover an area of approximately 15 million square kilometers, and in the late summer months would cover approximately 7 million square kilometers. Here we see the reduction of sea ice extent over the past 40 years, with 2012 having the least amount of ice coverage at the end of the summer. In recent years, the retreat of Arctic sea ice has been driven by solar energy being absorbed by open water, heavy winds from the south bringing warmer temperatures to the region, and advancing winds causing vast amounts of ice to exit the Arctic area. This is of grave concern, as the sea ice in the Arctic has acted as a global shield, reflecting a substantial amount of the sun's energy back into space. The increased rate of Arctic ice melting is being caused by increased absorption of solar radiation due to large open ocean areas being exposed. Additionally, the surface air temperatures are rising due to an increase in carbon dioxide concentration. This surface air temp increase is more than double the global average. With the reduction of sea ice in the region, this has opened the potential for regular use of Arctic sea routes for shipping. This could lead to chemical and physical changes in the marine ecosystem. With the passage open longer, this permits more and more shipping traffic to navigate the Arctic. These ships can potentially bring pollution to a once pristine environment. Additionally, with increased access, many countries are seeking excessive claims to the Arctic in order to access natural resources in the area. This type of behavior could be a catalyst to increase military tensions in the region. There may be hope on the horizon, though. Today, the Arctic Ice Project, formerly known as ICE 911, continues to test and develop solutions to prolong the life of the Arctic ice. Over the years, they have developed a product made from non-toxic silica in the form of beads that are spread over the surface of the ice to reflect energy back into space. Ice thickening is another way engineers are aiding in preventing ice loss. This process has been employed for years by oil companies to build ice roads and islands for oil production. During the winter months, temperatures can drop to minus 58 degrees Fahrenheit. When seawater is pumped from below the surface and sprayed on top of the existing ice, it freezes in a matter of minutes, thickening the ice. 1 meter of additional ice can last throughout the summer, restoring that protective reflective sheet of ice and slowing the warming of the oceans. Civilization must do their part to reduce carbon emissions that accumulate in the Arctic and contribute to the meltdown. This has been Matt Guilfoy. Good day.
It's the end of the world as we know it. It's the end of the world as we know it. It's the end of the world as we know it. I feel fine. 6 o'clock TV hour, don't get caught in 4 tower slash and burn return. Listen to your